This video will cover the Characterization tool, which is the generic tool name in the function list. This tool will detect clusters or blobs of pixels by detecting an intensity difference from a reference background intensity level. It is a very flexible tool that can be used for counting, flaw detection, and analyzing the size, center of gravity, and other characteristics of the detected objects, including the max and min intensity, as well as a volume of intensity difference. This characterization tool can also be found in the other tool categories of the CVX, including the stain flaw category. It is known as contrast with background. In the position angle category, it's known as dark or bright clusters. It's also known as dark or bright clusters in the count category, and in the dimensions geometry category under detect point, you will find it under dark or bright clusters. No matter what the selection, it's all the same tool, the characterization tool. For this example, we're going to add the tool from the function list. As with all tool setups, if you haven't registered an image yet, it will prompt you to register a master image. So we'll go ahead and do so. So what we'll do is we'll store this kind of shaded image as a reference image, and we can work off of that to build our tool. Next, we need to set up our inspection region. You can choose from rectangle, rotated rectangle, circle, oval, or ring for this tool. We'll leave it as rectangle. So basically, this is the area of interest on where you want this tool to locate and detect your objects. So for this basic example, we want to locate and detect these shaded objects on the screen here. So I'll set the inspection region for pretty much the entire field of view. As you're setting this tool up, it will be useful to take a look at what's known as the contrast view. So if you switch the view to contrast, the image will change over to this view. And what this is basically it's showing you the areas of difference in contrast level from the reference background. So areas of black are no change, and then areas of blue, green, yellow, red, those are changes of contrast that have passed a certain threshold that we'll explain. So the lighter blues are smaller changes, greens are a little bit higher changes, then it turns to yellow, and then red are pretty high changes. So it's almost like a weather map. The darker the red is, the yellowish, those are bigger changes, and the lighter blues are less changes. So, and you could switch back and forth between filtered and contrast view as needed. The filtered view is the grayscale view of the image. If you're using a color camera, the CVX will automatically convert the color image to a grayscale image using the average red, green, blue levels of each pixel. So that's what you'll see in the filtered view. Now we can cover the detection conditions of this tool. So we'll start with the reference intensity. What this is the baseline intensity level that's used when this tool is calculating the differences in intensity. It can be set for various conditions here. Its default is median. So what it'll do is it'll take the median contrast level within the entire inspection region. As you can see in this image, it's 128, but it depends on the target, of course. You can also set it for average. So again, it'll be the average grayscale intensity of the entire inspection region. You can also set mode, which is the most frequent intensity level that occurs in the inspection region, or you can specify a specific level if you want from 0 to 255. So if you want to specify a set reference, that can be done as well. You just choose that and set the level accordingly. So for this example, we're going to go ahead and leave it on the default, which is median. The detection target setting can be used to dictate which type of targets will be detected. As a default, it will look for bright and dark targets that occur. What a bright target is pixels that are brighter than the background intensity level or reference level, and dark targets are pixels that have differences that are lower than the base level. So you can see as a default it's set for both. If I change over to that contrast image, you can see here's our changes of contrast. You'll also note the detections here. The plus sign indicates a target that's brighter than the reference level, and a minus sign indicates targets that are darker than the background level. You can choose just bright only if you'd like, so to ignore any changes that occur darker than the background level, as you can see here. You could also choose just dark, or you can choose a setting called individual. And the only difference with this is it will look for bright and dark targets, but you can set two different thresholds, one for dark, one for bright. For this example, we're going to leave it on the default, which is bright and dark. The intensity threshold level is that intensity difference level for which a target becomes a detection. In other words, as it's comparing the intensities of the pixels to the reference base level, if the difference is greater than the level here, it's a detected target or blob. So in this case, the default's 10, and that's indicated here in this graph here. You can see the base level of 128 is this center line here in blue, and then these two green lines are our threshold, the 10. So if any pixel differences go beyond this threshold, they become detected targets. And you can adjust that as needed, but for this example, we're going to leave it as 10. The next setting we'll cover is the segment size under segment settings. So how this tool actually works is as a default, it's not comparing every single pixel to the background reference level. It's actually creating a segment. In this case, it's 16 pixels in size, so 16 by 16. And you can see, and that's indicated here by these squares in the upper left part of the screen here. So what it does is it takes the average intensity inside the segment, shifts by a certain amount, about a quarter of the size, calculates the average intensity again, and so on. So what it does is it compares the average intensity of the segment to the reference level, and that's what is used for detection. And if it passes our threshold that we mentioned earlier, it becomes a detection. So if I switch over to the contrast view, you can kind of see that indicated by here. As you can see, the segment size is set for 16. So that's kind of why these targets kind of group together, because the segment size is 16, and that's what it's comparing. So if we want to, what we can do is set that segment size down. So to see the lower I make it, I can set it down to 4 as a default. You can see we have separation between these targets. The segment size can be adjusted according to the application. The smaller you make the segment size, the more finer details it can pick up on. And the process time will be affected as well, the smaller you make it. As a default, you can notice that the size increments in levels of 4. If you want to, you can override that by clicking the detailed settings here. You can notice here it's called high speed mode. So if you uncheck that box, it will let you freely set the size in any pixel size that you want, all the way down to 1 if you'd like. So you could set the segment size all the way down to 1 single pixel, if need be. The blob settings here can be used to filter out unwanted detections. The detection count is the number of targets to be detected. As a default, you can see is set for 10, but you can change that as needed according to the application. We'll leave it at 10 for this example. The lower area filter is a size filter. So if the object is less than 100 in size, pixel size, it will be filtered out, as you can see, as a default. And that also can be adjusted as needed according to the application. There is also a lower volume filter, and volume basically is an intensity differential volume. So basically each target, it will add up the total difference of intensity according to the reference of the target, and that becomes its volume. If you click the detailed blob settings here, you can even set up more filtering conditions. If you want to use the major minor axis, you can check the box here and turn that on. Notice if you do turn this on, you need to make sure you set the angle range here. So if you turn that angle range on, you can also use major minor axes as filter conditions. So once those are activated, you can see they're down here. So we can filter off any of these conditions. Axis ratio, major axes, roundness, how round an object is. It's a factor from 0 to 1. We have a maximum intensity difference of the object, average intensity difference, and again that volume. So you can filter off unwanted targets by any of these conditions by coming into these settings here. Also, you can set the detection order in the detailed settings. As a default, the detection order, or how it numbers these objects, is area descending. So the biggest object is target 0, and so on. For this example, we're going to go ahead and do X ascending. So we're going to number them from left to right in that order, just to kind of help explain what's going on. Also, you can set what's called the judged label. That's the target in green, the main target. As a default, it's just the first target in the list, but you can change that accordingly. So if this judged label is set for specified, the limits that you set up will be only for that specific target. If you want the pass-fail limits to apply to all targets, just make sure you select the all setting here, which we will do. Finally, a couple other settings here. The fill holes setting will be used if you have like a donut-shaped object that has a void in the middle. What you can do is check the box to fill it in. So as it analyzes the size of the object, it'll consider it a filled-in object versus a donut-shaped object. And active border can be used to ignore targets that hit the frame or the inspection region frame. So if I move this over just to kind of show you, see how this target hits the frame? If this is checkmarked, the target will be ignored. So those are two additional filter settings that you can use. If you want to view some of the results of these detected targets on the screen here, you just can go up here and click the numeric icon here. It switches between the help file and the numeric readout. So here you can see all the detailed results. The unit time, all the different parameters, max differential, intensity reference, etc. So the total area, it'll give you a total area, which is the total size of all detected objects, the number of objects, and then the judged label, center of gravity, major axis. If you click the arrows to the right and left, you can toggle between all the different targets. So if I keep going here, you can see here's label 1, its center of gravity, major axis, area. So you'll get the detailed results of all the different labels. Bright and dark, it can also tell you if the target is bright or dark according to the background. So if it's a 1, it's a bright target. If it's a -1, it's a dark target, as you can see here. So if you scroll through all these detailed results, you can see the different results, including volume. So you can see the volume, again, is kind of the total area of, or the total difference of contrast from the reference level from the target. So the bigger difference that target is compared to the reference, that higher the volume will be. Just to show you one more example, I will trigger on another sample image we have here. You can see we have some various objects that we're detecting, 4 of them, and I'm just going to compare the size and volume of these first 2 targets, just to give you an example again of the size and volume. So if I switch this view over to the more detailed view, you can see target 0 and 1 here. They're roughly the same size, so you can see the area, 11,000 some pixels, 11,000 some pixels for. So these are about the same size, but notice this target has more change of contrast. So what we'll do is we'll look at the volume of this target as well. So here's the volume. Notice even though they have the same size, the volume of target 0 is much greater than the label 1. So that's another benefit of this tool, is you can actually get a difference in the more change of contrast that occurs, the higher the volume. So you can differentiate bigger changes in contrast versus smaller changes of contrast, even though they're the same size object. So the last step of the tool would be to set up the judgment conditions. In other words, the pass-fail criteria for the tool. Now, this tool is so flexible, so there's a lot of things you can do. It depends on the application. You could fail it based off the count if you want. So I can put an upper or lower limit on the count. I could fail it based off the size of the object, so if any of them become too big or too small. I could also pass-fail it on the volume. Again, upper lower limit if it need be. If you click the detailed settings, you could also set a tolerance on the total area, which is just the total number of detected segments or pixels. Also the center of gravity, so the position, the major angle, as well as the average intensity difference, maximum intensity difference, foray, parameter, roundness. So you can see there's a lot of different things this tool can do, and there's a lot of different ways you can pass and fail things. In summary, the characterization tool is a pretty flexible tool that can do a number of things. Some examples: detecting flaws on a target. So if you're looking for any kind of blemishes, things like that on a target, you can use it for that purpose. You can also use it just to locate an object based off its center of gravity and angle of major axis if you want. And another example is just simply counting things if you want to count detected objects on the screen. So very flexible tool that has lots of purposes.